What's up, everyone? We're going to be talking about domain and range tonight for homework. We're talking about how we can incorporate inequalities, compound inequalities, to be able to write a concept of domain and range. And to be honest with you, I think this is kind of a challenging topic for this course, but it gets harder. So I'm really wanting to give you a firm grasp of domain and range in this class so that moving forward you're not as confused. So domain is the main concept of how far left and right the graph goes and how far up and down the graph goes for the range. So domain, it has to do with x, range has to do with y, and again it has to do with like possible y values, possible x values. So for example, this point is 4, 0, and it starts moving left, so then I have like 3, 1, okay? And so we can tell already that the y values are already increasing. You see them go to 2, and then eventually they hit 3, and later they'll hit 4, okay? So the y values are increasing. They'll never go below that, okay, because that's where the graph kind of stops. So in terms of just talking about, domain first, domain goes from 4 left. Okay, if you use your pen and you say, okay, I started here and then I moved left forever and ever and ever, basically you're saying that all the values of x have to be less than or equal to 4. There's no value over 4 that'll be a point with x as the value, okay? So then I start thinking about the other direction, and basically it starts at 0, and then I get 1 and 2, and it's going to keep moving up because the graph goes up from right here. Okay, it always goes above that value. Well, this value is 0, so basically y has to be greater than or equal to 0. Okay, so the x's are less than 4, 3, 2, 1, 0. The y's are greater than 0, 1, 2, 3, 4, and so that's how we're going to write that. Now this passes the vertical line test. This is considered a function, so I want to say yes. There's no repeating x values, okay? Which means, like, for example, here, this is 4, 0. Is there another point like 4, 2 or 4, 1? Well, there's no point above it or below it, so that's the only point that has 4 as an x value, and that's where we are getting down to the definition of what makes something a function. So one thing I told a student at the end of class is that you can sometimes box the picture in. And if you can box the picture in, then it really helps you kind of study how far does it move left and right, how much does it move up and down. And so for this one, it looks like it goes as left as -2, as far right as +2, and so for my x's, they're between there, and it looks like the graph does actually touch those places, okay? And the range, looking like how far up and down it goes as low as 1, and it goes as high as 5. So basically all my y values are between 1 and 5, and they actually touch in those places. So I want an or equal. Okay? So is this one a function? Does this pass the vertical line test? It does not. This point right here is 0, 1, and the point above it right here is 0, 5. So the zeros are the x values, and they repeat, which means when I plug in 0, I don't really know what I get. I could get 5 or I could get 1. Well, if it's a function, that means you always know what you get out, and if there's options for an input like this one, then that's not going to function correctly, so that's not a function. It fails the vertical line test. Okay. Now this one goes forever right. Okay, I'm going to angle it out a little bit, but this is moving to the right as it goes up, and so does this one. Okay, I tried to make them a little more extreme because it looks like it's going straight up, but I promise there are corresponding y values for everything. Okay, so in terms of left and right, that's going to be all real numbers. Now, if you want a shortcut, when you get to Algebra 2, or actually when you get to college math, one of the things that they do is they show this phrase, all real numbers, by doing like a capital R with like 2 vertical lines. So that symbol encompasses the words, all real numbers. So you could do this symbol instead of writing all real numbers. So we'll see who comes up with that. That's how I'll know you're watching the video. Okay? Now the range is different. It's going up forever, but it only goes as low as the y-axis. And the y-axis, 6, 5, 4, 3, 2, 1, this is 0. So again, we see the y values do not go below, sorry, I was thinking about they don't go below. They're all above 0. It never goes below 0. So all the y values in this are 0 or greater. So that's how I'm describing, like, hey, the y values don't go below, they all go above 0. Now, is this a function? When you draw a vertical line, does it only cross once each time? Yes. There are no repeating x values in this graph. There's no place where there's 2 points for the same x value, like on top of each other. Okay? So right off the bat, I'm like, I'm not sure if that's going to be a function. That seems to be repeating. So I'm going to go ahead and put no in here. That's not a function. Okay? And so when I start thinking about domain, again, that's left to right. So it looks like it goes as far left as -4, and it goes as far right as 3. So in terms of my domain, from -4 to 3, I've got my x value. So we've been talking about like the open and closed dots. And so what I have here is an open at 3. So I don't want that line that says or equal. I just want that to be less than 3. But if you notice on the left side, it doesn't really do an open dot. It doesn't necessarily do a closed dot either, but I can kind of assume in this case that it does actually touch at that point, -4, -2. So that one's going to be or equal. So when I flip this and I think about up and down, I'm thinking, okay, the graph only goes as high as 5, and it only goes as low as -5. But if I'm going to say that, I need to do it from least to greatest. And I need to ask myself, which of these points are they really touching? Like, do these points actually touch at these places? Well, again, that's what the open dot suggests, is that they don't. That's simply going down all the way to that place, but not actually touching there. And the same thing here. We're going all the way up to 5, but we're not touching 5, and we're not exceeding 5. So these inequalities describe possible x values and possible y values for any point on this graph. Okay. All right, so another one that I'm seeing is shooting out to the left and shooting out to the right. That tells me not only that they go up forever, but because they are angled out, they go left and right forever. So again, I hope you're thinking about that. All real numbers as an answer. Hashtag numbers. Okay. Now the range is up and down, and I'm seeing that it goes up forever, but it really does kind of stop at one particular y value, and it never actually hits -6, -5, -4, but it does have -3. So I want to say all of my y values are greater than or equal to -3. And I'm seeing that this would pass the vertical line test. I'm not seeing any x values that repeat, so I'm going to go ahead and say that yes, that is in fact a function. Okay. So honestly, I'd love to see what y'all put for these last two. If you have any questions or you want to check your work, you can email me or come in early. But these last two, I really want to see what you come up with on your own. And for 100 on your homework, just make sure you try every one. Don't worry about being right or wrong. But all your answers should look something like the ones we talked about, where you're using compound inequalities. Not always. Sometimes you just have one inequality from this value up or from this value down. But for the most part, we're using inequalities, unless the answer is all real numbers. All right. Thank you all so much for watching this video, and I will see y'all tomorrow.